Hello everyone, welcome to the Achievers YouTube channel. I am Bhumika AS, PS College of Engineering Mandya from Electrical and Electronics Department. In this video, let us know about the one of the property of DFT. It is circular correlation. First we have to know what is circular correlation. Circular correlation is the statistical technique which is used to measure the relationship between two circular variables. Let us start with the circular correlation property. Circular correlation property. Statement of circular correlation property is if n sequence of x of n with respect to the DFT x of k, another sequence y of n with respect to the DFT y of k. The circular correlation represented in R x of y of L tilde with respect to the DFT capital R xy of tilde of k, that is equals to x of k into y conjugate of k. This is the statement of the circular correlation property. It is defined as Rxy of L tilde is equals to summation of n equals to 0 to n minus 1 x of n into y conjugate of n minus L mod n. Here, circular correlation property is defined as the multiplication of DFT of one sequence and the conjugate DFT of another sequence. It is the definition of the circular correlation property. Let us prove the circular correlation property by using this equation. In this equation, n is represented as the total number of samples in the given signal, and the double brackets represents the circular shifting or convolution of the sequence. Hence, from this expression, we come to know that this is the formula of circular convolution of x of n and y of n minus L. So, this is represents the circular convolution of x and y sequence. Hence, this equation can be written as Rxy of L tilde is equals to x of L circular convolution with y conjugate of n minus L. Apply the DFT on both the sides. DFT of Rxy of L tilde is equals to DFT of x of L circular convolution with y conjugate of n minus L. From the circular convolution property, DFT of circular convolution of two sequences is equal to the multiplication of their spectra. Then this equation is written as Rxy of k tilde is equals to DFT of x of L into DFT of y conjugate of n minus L. From complex conjugate property, this DFT of y conjugate of n minus L can be written as y conjugate of k. Hence, the final expression becomes Rxy of k is equals to x of k into y conjugate of k. This is the expression for the cross correlations. There are cross correlations and autocorrelation, and also circular correlation. This is the expression for the cross correlation. In case of autocorrelation, this means the signal is comparing with its own complex conjugate value. Here we can consider the second sequence is nothing but the complex conjugate of first signal itself. Autocorrelation can be written as Rxs of L tilde is equals to summation of n equals to 0 to n minus L x of n into x conjugate of n minus L mod n. This can be written as Rxs of k is equals to x of k into x conjugate of k. Final expressions becomes Rxs of k is equals to mod of x of k whole square. This is for the autocorrelation. Let us solve one problem on this circular correlation property. Consider endpoint sequence x of n is equals to 1, 1, 2, 1 and another sequence y of n is equals to 2, 3, 1, 1. Using matrix form, we can solve this problem easily. Consider y of n sequence as first matrix and x of n sequence as second matrix. Y of n matrix should be in 4 cross 4 and so X of n matrix should be 4 cross 1. Then Y of n matrix should be filled in 4 cross 4 matrix. Fill the first row as it is given in the problem, and next row for next row last element in the first column and another 3 elements should be in clockwise. Fill the another 2 rows in clockwise and multiply these two matrix, and multiplication of these two matrix is 2 plus 3 plus 2 plus 1 and 1 plus 2 plus 6 plus 1, 1 plus 1 plus 4 plus 3, 3 plus 1 plus 2 plus 2. We can get final output 8, 10, 9, 8. Finally, R of xy circular correlation is equals to 8, 10, 9, 8. We can solve easily in this matrix form.
It is all about circular correlation property. If this video is informative, please like and subscribe. Thank you.